Hello, everyone, and welcome. I'm delighted to have you all with us today for this LCA Methodology webinar. So my name is Noa Gazbo from CA in France, and I will be the moderator for this session. So just a quick reminder, please, before we start, please keep your microphone muted during this presentation and raise your hand or use the QA chat function if you'd like to ask questions. So today we have an exciting program ahead with 4 presentations. We will start with a short introduction from our project coordinator, who will set up the scene and provide some background on the Cactus European project. Then we will move on to 3 individual presentations, each lasting about like 15 minutes, followed by 5 minutes of question after each talk. So please be free to ask your question. And finally, we will close with the panel discussion where our speakers will come together to exchange view and interact with you. So we will really encourage your participation during this part. Your thoughts, experience, and questions are very welcome, and we will be happy to answer them. So without going further, let's get started. So we will open today the session by introducing the Cactus project with our first speaker, Ioannis Tsakanas. So Ioannis, the floor is yours.
Hi everyone. No, first check, can you hear me? And can you see my screen?
Yes.
Okay.
Yes, perfect.
Good. Then welcome also from my side. It's a pleasure to kick off this webinar. In the framework of Cactus project, as Noah mentioned, with a brief introduction in the project itself. For those that are not familiar, especially, Cactus is a collaborative project funded by the European Commission under Horizon Europe. It brings together, as you see here, a consortium of 9 partners from across Europe and Latin America, total budget of 1.5 million euros and a duration of 24 months. Our work and motivation are driven from a critical challenge we identified early stages in the proposal, the fact that the long-term performance, reliability, and O&M in photovoltaics are heavily dependent on climatic conditions. Many regions with high solar potential, such as those in Latin America, lack in dedicated testing facilities. On the other hand, European research infrastructures, you see examples of such infrastructures here like CA, Tecnalia, Eurac, need broader climate validation for global deployment. So this is the precise gap that Cactus is designed to bridge. And move on in the next slide. You see an overview of the research infrastructures involved in the project, and we stress the importance of diversity of climates in these locations. In France, we have ECA, ESRF, and ELL. In Chile, we have Atamostec. In Italy, we have Eurac. In Spain, Tecnalia. And in Colombia, we have the National University of Colombia. And our core objectives through these diverse infrastructures have to first to develop standardized testing protocols for PV under diverse and extreme climates, to advance fundamental knowledge in PV degradation mechanisms in different climates, and ultimately to provide industry policymakers and investors with tools that they need to increase PV systems bankability and sustainability. I will close with this slide just to show you that we are everywhere active. I'm pretty sure if you are involved in the PV research industry or simply policy making and standardization, you've heard of us, I hope. We've been active the last almost 2 years in all the fields. In scientific publications, we have already 3 published journal papers, another 3 in the pipeline, and more than 10 conference presentations. We have a strong presence in the scientific community through keynotes, session chairs, and we organize already several workshops and webinars like this one today. A very important feature, a key pillar, I would say, to foster direct exchange of knowledge and training. We develop extensive training activities and staff visits between our regions, Latin America and Europe. And we focus on multiple areas ranging from PV reliability forensics, really a microscopic scale, up to operations and maintenance in different climates and sustainability. We finished in 2 months this project, less than 2 months, I would say. What we're not done yet with these activities. So for your information, on November 4, we will organize our final public workshop in hybrid format, in person in Granada and online, in collaboration with our sister project, EnergyTran. We have already secured a great and diverse lineup of keynote speakers and panelists. Well, official announcement is not out yet. Registration information, detailed agenda, and the announcement will be out in the coming days. So if you are interested, the event is public. You should stay tuned through our different communication channels. So I will not stay more. I think the floor is here to our experts to discuss today LCA methodologies. So I will now hand back the floor to our moderator, Noah, who will guide you through the detailed agenda. Thank you very much.
Yeah, thank you, Anis, for these details. And maybe I add one more thing about scientific publications. So for sustainability and in the context of this webinar, we are working, the partners are working on white paper who will be published soon. So be free to have, we're happy to have your feedback maybe or some review about this white paper for sustainability of infrastructure and for PV modules and PV systems. So now we will move to our first, let's say, technical presentation about sustainability with Cristina. So Cristina, maybe a small presentation. So Cristina is POLACCI, from Eurac, which is originally from Rome, but based in Bolzano, Italy. She holds a master's degree in mechanical process engineering, and she's specialist in environmental assessment for renewable energy system now since 2022. Cristina also is involved in a lot of European projects like Nexus, Cactus, etc. And today she will present environmental LCA methodology for PV system. So Cristina, the floor is yours.
Thanks for the introduction. I will share my screen. So you should see the presentation. Okay. And you can hear me well. Okay. So yes, the idea of this presentation is to for you to have a general overview of what are the environmental LCA methodologies of PV system and what are in general methodologies for sustainability assessment and especially for PV system. So what we will see is a generic overview of the tools available to measure life cycle sustainability, because some of you might be familiar with this topic, but some of you might be less familiar. And then to try to answer to the question, are PV systems sustainable? And then to talk about challenges and limitations that can arise when doing an environmental LCA of PV systems. So in the meantime, you can ask questions in the chat, and in the end of the presentation, you can open your microphone and just ask some direct questions if you want. So what are the tools to measure the life cycle sustainability? First, it's really important to start from the basis of what is sustainability, because we always talk about environmental sustainability, but it's also important to take into account the economic part and the society impact. And plus, for a technology to be really sustainable, it needs to be feasible and industrially ready to be on the market. So there are already a lot of life cycle assessment guidelines and standards available. You see that the size of the star is proportional to the level of standardization of the guidelines and of the methodologies that are available. So I would say that the environmental one is one of the most standardized topic. We have the ISO 14040 series of standards that provides really a good guideline for this. And for the PV sector in particular, the International Energy Agency Task 12 is one of the most used guideline and reference to perform this activity. On the other hand, for the economic part, there are some ISO guidelines and other standards for life cycle costing, but more on the construction sector. And generally, for the electricity sector, what is used is to evaluate other parameters that can be life cycle based or not, like the levelized cost of electricity, where we have the euro per amount of electricity produced, or the minimum sustainable price for a given technology as well. And then related to the society part, this is one of the less standardized, but Anna in the last presentation will give you more information on that. We have guidelines from UNEP and very recently some ISO standards were published as well. So a life cycle assessment that takes into account all these topics is called Life Cycle Sustainability Assessment, LCSA. Now, to give you an overview of what are the phases according to the standards, we have in the life cycle assessment 4 phases. So the first one is the definition of the goal and scope. Here we define all the assumptions of the analysis. So why, who is the stakeholder, who are the stakeholder involved, what is the scope, what are the functional units, system boundaries, etc., and etc. The second step, which I would say is the most challenging one, is the inventory analysis. Here we collect data of inventories of all the inputs in terms of raw material and energy flows for all the steps that we want to analyze, and also the outflows, so the emission to air, to soil, to water, the waste, etc. This process can be iterative of several steps, and the inventory might need to be refined several times to be accurate. And then, of course, there is the impact assessment part. So when after the analysis is done, we draft all the factors are analyzed. The impact can be also shared with the normalization factor to convert all the units of measurement into one, and optional step, they can be also weighted to have a single score impact, but with careful, because this might arise also to subjectivity of the weighting methods that used and can lack in transparency. So to give you an overview of what are the most important, the most used environmental footprint categories, there is not only the climate change impact, but generally the methodologies analyze also other impact on human health, on ecosystem health, and natural resources like land use, ozone depletion, water depletion, etc. And why do we study these impact categories? Is because those are related to the boundaries of the Earth ecosystem that allow the planet Earth to be healthy, let's say. And you probably know this graph from a study of 2009 already, when 7 boundaries of the planet Earth were considered, and already back in 2009, 3 of them were crossed. And if we go in time, we can see that now in 2023, already 9 boundaries were assessed, and 6 of them were crossed. So this to stress the importance of why it is important to take into account all these different impact assessment. And finally, the last step of a life cycle assessment study is the interpretation of the results. In this stage, really, the conclusions are drafted based on the objective that were defined, and then there might be different iterative phases where a sensitivity analysis might be done to improve the analysis, or data quality assessment might be done to improve the quality of the data, etc. There are also other type of assessment that can be life cycle assessment. For example, material criticality assessment. For this, actually, there are a lot of tools. These that you see in the screen is just some of them. So as you can see, the methodology is not so standardized, and it's considering all the three factors of environmental, economic indicators, and also society indicator. And also another assessment that can be performed in terms of sustainability, which is, I would say, not yet very well standardized and lacks of harmonization, is the circularity assessment. And as you can see in the screen, there are different indicators, different methodologies to perform this kind of studies. And sometimes when you are in front of a circularity assessment study, it's difficult to draft conclusions that are not then comparable with other studies. And so after this quick overview, we can now try to give an answer to the question, are PV system environmentally sustainable? And see an example of results. First, if you are not familiar with PV modules, how a PV module is made, in terms of material, you have the core of the PV module, which is the cell, in particular silicon cell, probably have a pointer, silicon cell, but in terms of weight in the module is only 3%. And then you can have encapsulant, which is made by polymers, and backsheet and front sheet, which can be glass, like in this case, or a polymeric. And then we have all the balance of system, which is all the other components, including the steel mounting structure, inverters, other electrical installations components like a battery. To transform the manufacturing of all the life cycle of a PV module, we can refer to this schematization. So it's possible to have very different life cycle assessment that can be, for instance, cradle to gate, including only the manufacturing stages up to the PV module, but can also be cradle to use if also the balance component and the system installation and the operation and maintenance stage are added to the analysis. Or it can be cradle to grave or cradle to cradle if also the end of life operation and recovery operations are included in the analysis. And as well, we can use different functional units, depend on the scope of our analysis, like 1 square meter of PV panel, capacity installed, or AC electricity generated, just to give examples. What is really important is not really what functional unit we use, but really to clearly declare what are the assumptions behind the study in order to make it comparable with other studies. And to give on some example of environmental LCA results, here we have a study from 2024 from literature, where we see the global warming potential, so the impact on climate change of PV system in different production locations. Oh, sorry, there's a typo here. And what we can observe from this graph is that the global warming potential is really depending on the production location, and also that the PV module is not only the major contributor, but also the balance of system has a very high contribution to the greenhouse gas emission. Then if we compare the photovoltaic, the global warming potential of the photovoltaic to other electricity production technologies, we can see that in general, the impact, even considering the entire life cycle, is low compared to the fossil fuel-based electricity sources, and more or less is in line with the other renewable electricity sources. So does it mean that solar energy is sustainable? Well, as we stated before, the global warming potential is not the only impact category to take into account when dealing with solar technologies and not the most important. In fact, when we see, for example, this graph related to different impact categories compared in terms of 1 kilowatt hour of electricity produced, we see that, for example, the material resources, in the material resources category, the PV has the highest impact even compared to natural gas or coal. So it's really important to measure all the impact categories. And I will conclude with what are the main challenges and limitation of an environmental study to summarize, and then to open the work to what will present Denet of the case study. So what emerged from this project and the other projects where we worked in this topic is that the main challenges are related to data quality and availability, because sometimes inventories that we use for these analyses are incomplete or outdated and are not representative to the current market technologies. Also, one of the main challenges is the regionalization of the data set. That sometimes is not properly addressed, and global data are used for simplification, but actually this might have a big influence in the analysis, as we will see later. And also results can vary significantly depending on the choices of system boundaries and functional units. So it's very important to transparently report all the assumptions. And yeah, the impact categories like ecotoxicity, material, resource use are sometimes less standardized than the climate change category. So we need improvement in that, as well as the social and economic aspects. And in general, some methodologies are more standardized and harmonized than others. So it's really important, especially when these tools are used for eco-labelings, to transparent communicate the assumptions of the analysis and to provide guidelines for harmonize this analysis. So I will conclude with some questions to the audience. So if you want, you can scan the QR code. I will give you some minutes to scan the QR code, and otherwise you can go to the website Mentimeter and manually insert the code. Maybe we can share the number in the chat.
Yeah.
Thanks.
I will add it.
Okay, thanks. No, sorry.
Okay, thank you, Cristina. So thank you for the presentations. I don't know if you received some question. Or yeah.
Let's see if I can share the answer from the Mentimeter. Yeah. Okay, you should see it.
Perfect.
So, yeah. Okay, great. So we have a lot of people that are already familiar with LCA.
But what about LCA for PV systems?
That's also a question that I could have had.
Noah, have you answered if you are familiar with LCA?
No.
Okay, and in this question you can write what are, according to your opinion, the most important sustainability concern of PV system, including all the sustainability aspects that we discussed. So just for you to know, these questions are useful for us in the Cactus project, because in this white paper we also would like to add a session dedicated to the feedback that we got from the workshops that we are organizing, and so it's also good to collect some opinion from the audience. Yeah, recycling, land use, one of the recycling and land use.
Land use, yeah.
An angel appears.
All of them.
All of them, point. Of course. Reuse as well is really important.
Reuse, yeah. But I think, yeah, raw material also. Recycling or reuse. There is some toxicity also.
Yeah, critical raw material.
Yeah.
And resource use that is very similar. Yeah.
Yeah, you have three, let's say, raw material, land use, and recycling.
Yeah, yeah. Waste.
Water waste classification also, yeah. Interesting.
Okay, critical raw material. Yeah, yeah. I think we
end of life. Yeah,
we have. Yeah.
Yeah, you have. I think we are aligned.
Yeah, we are aligned definitely. And in this question, this is more related to the next presentation dedicated to the case study of PV in the desertic environment. So, according to your opinion, which is the major challenge in installing PV in a desertic environment? So it can be a problem related to temperature, to transport of the material, or others. Just feel free to use exactly your fantasy. Cost of logistic.
Denet will answer the question, I guess, in her presentation. Yeah. Soiling and temperature. Grid connection.
Yeah, cleaning as well.
Yeah, it's important, I think. UV impact. Soiling. Cleaning.
Lack of qualified labor as well.
Yeah. We have the social, we have the economic, we have the environment, everything.
Yeah. Windstorm. Then also every desert is different. So
yeah, exactly.
It's a bit tricky as well to have this kind of generic question, because then every desert is different.
Windstorm, yeah. Interesting.
Yeah, I think even in this case we are the answers are more or less aligned. Yeah. Okay. That was the end of the Mentimeter.
Thank you. Thank you. Thank you, Cristina. So now we will move to our next presentation with Denet. So Denet is a PhD who works in University of Antofagasta. Please correct me if I'm wrong. Antofagasta in Chile, and she is working basically on the environmental impact, LCA environmental impact of PV system for the Atacama Desert. So please, Denet, the floor is yours, and tell us more about the problem of PV system in the desert.
Thank you, Noah, for this introduction. I will help you with this slide.
Yeah, thank you.
Okay, give me a minute.
Yeah, if you can put it full screen.
Okay, can you see the full screen?
Yeah, perfect. Yeah.
Okay, good afternoon for everyone. Thank you for joining to this presentation. Today I would like to present the results applying life cycle assessment of PV system in desert environments, specifically the case study of the Atacama Desert. Before going to the details, I will to share the structure of my presentation. First of all, I will introduce the context of the solar deployment in Chile and the role of the Atacama Desert in the as a place of the capacity. Some of the limitations of conventional LCAs in utility scale PV. Cristina has mentioned some of them, and our approach to fix this problem, a parametric approach, and some conclusions about the results in general. So, in order to introduce, sorry for my English is a little bad, but I will do my best. Chile is a regional leader in PV deployment. We have experienced a big growth in the last 10 years. And today we have a capacity installed of 11 gigawatts in the energy mix. And that represents almost 30% of the capacity installed. And the expectation is to reach at least 98% of renewable matrix in the 2050. And different regional studies, as you can see here in this figure. Let me show you. Okay. Different regional studies have calculated that there is a potential of more than 2,000 gigawatts, and all this capacity is possible to install in the north of the Chile. In the north of the Chile is almost installed all the capacity of the country. We are talking about most of the 90% of the utility scale segment, mainly by the great condition of the Atacama Desert, the very high radiation and the clear skies. According to the Köppen classification, Atacama Desert is divided into several zones, but the predominating zone is the BWK, that means cold desert and dry. And this is a good news for us. We have no problem with the landscape. We have a lot of space for installed capacity. We have an area of more than 150,000 kilometers. We have among of the most favorable radiation levels in the world, low operational temperature for PV, and we have the problem to the altitude that is a good condition, but have two challenges to consider. Atacama Desert face a lot of challenges, as you say before. We have a specific characteristics, a high humidity, and effect knowledge as Camanchaca that have a direct impact in the performance of the technologies. For example, in the morning, we have a lot of fog with high humidity, and after that, we have a lot of radiation that dry all this condensation, And the result is a specific cementation effect in the PV panel and very high possibility of cleaning only using water. We have an extreme UV level that have a direct impact in the performance of modules and caused overheating due to the altitude in the vertex, for example, degradation of polymers. We have very hard sandstorms and blasting, these devils, and we are two in the most seismic country in the world. We have the problem of the water scarcity, and under the soil, we have these characteristics of very, very hard saline, hard and collapsive soils that have a direct impact in the design, mainly of the mountain structure, for example. And we have this characteristic of very, very long distance between PV plants and cities. The average distance is between 50 and 100 kilometers from PV plants for the closer city. All these characteristics, as I said before, have a direct impact in the lifetime of the components. We can see here in the right the difference between lifetime compares with the standard conditions of Europe. And for example, all this data was extracted from local interviews. And for example, we have a big problem with the inverter lifetime. So in the literature, we can see different studies applied in PV system at utility scale. The results are very heterogeneous. But one of the main questions is if this heterogeneous in the results is due to the difference in the system definition, the quality of the data, the temporal representativity. But the principal point is that all these studies have not represent very good the different typologies of components, and it is difficult to understand if this change, different results, are because there is not considered all the characteristics of the PV plants. So in order to face that, we have proposed a parametric model. And the idea of this model that considers a lot of characteristics of the plants, I'm talking about the geometry and the designs, the kind of technologies. We can devise the components by materials, specific materials, introduce data respect to the geospatial context and operational data. And the idea to applying this kind of model is to better understand how each decision impact in the final result. We divide the model in 3 stages. The macro level, we are talking about the PV plants in the complete as a complete system. The second is the meso level, and in this level is where all the designs detail are introduced, and the micro level, where all the inventories, process, and materials are considered. I will show you this case study. Is a PV plant that are installed 65 kilometers from the Antofagasta city. It's a 1 megawatt plant, and have specific innovations that we consider in the analysis. For example, the use of micropile is one of the foundation typologies that is common here. And in the case of the micropiles, for example, we use concrete for in order to reinforce the structure for the incidence of the soil in the structure, the very, very saline soil. And we consider in this case study string inverters and external cabling in order to avoid the movement of the land. The functional unit considered was 1 kilowatt-hour of electricity delivered to the grid at medium voltage over an operational lifetime of 30 years. We consider system boundaries in a scope grade to grade, both included. And we use the receipt method at the methodology, calculus methodology. If we compare our results with other results in the literature, we are in a very good band, but for example, it's hard to say if this result is due to the quantity of material we consider, because we have a lot of details of all the materials in the PV plant. For example, in the case of the electric system, we declarate a quantity of cabling almost the double of these quantities that are reported in EcoInvent as a baseline. You can see the report in this article. And this, I will show you some of the results. First of all, it's important to note that the manufacture stage is the most important contribution in the results. But in general, for example, the global warming potential, the climate change is one of the parameters that is considered. And if we only see these parameters, seems that the module is the principal contribution, and that is true. But if we consider other categories too, we can see how this change. For example, in the case of these three impact categories that have the most important contribution, we can see the normalized impact, and we can see how, for example, the human carcinogenicity toxicity is influenced by the system, by the mountain system. And for example, in the case of the FECO or MECO, we can see the contribution of the cabling. It's important to say too that for our case study, the operation and maintenance is one of the principal stage. You are right, thinking about the relevance of this stage, because we have this problem to a big replacement of components, and all this charge is introduced in this stage. We can see an example of the mounting system analysis, the contribution, for example, of the steel. In our model, we consider a single axis tracker So we have the torque tube, the support column, the purlins and secondary rails, all the drive and control system. Normally, this kind of detail is not presented in the literature. Mainly the drive and control system is always, in all the cases, not considered. And here it's important to say that the quantity of materials have a very big impact in the result, but it's important to know that the different materials have a even when these materials is in a little quantity in the system, it's important to know the direct impact. Here I show you how our model looks. For example, which are the possibilities in order to select different typologies. And for concluding this presentation, I would like to highlight some of the principal results. First, site-specific design matters. The environmental performance of PV plant strongly depends on local conditions, such as radiation, soil composition, corrosion level, etc. So every design should adapt to its context instead of following generic assumption. Second, the conventional LCA approaches underrepresented desert environments. Most databases and models were developed for mild climates, standard climates, which mean they underestimate the real impact of maintenance, material degradation, or cleaning in places like Atacama. Third, the parametric modeling enables to adaptive assessment by integrating the environmental and design parameters, lifetime of cleaning frequencies, and see how this decision affect the overall footprint. And finally, this work moves toward circular and localized PV design. Supports a transition from static environmental analysis to a more dynamics and site-aware framework. One that helps engineers and researchers design PV systems that are not only efficiency, but also durable, recyclable, adapted to their environmental conditions. Thank you for your attention.
Thank you, Denet, for this nice presentation and this interesting work. I don't know if there are questions from the audience. Please feel free. Okay, meanwhile, I have maybe one question for you. Okay, let's see, we see the model. I think it's really interesting because here we focus on the global system, not only the PV module, because we use it to look at the module. Maybe what are the main challenges that you had in order to develop this model, basically?
Okay, the principal challenge was to collect data, specific data for these conditions, because if we use database as a reference, international database, we not find specific data. So what we had to do was to collect data from the from the PV plants that are installed here in the Atacama Desert with the managers of these plants. So was a very site data collection. For that is representative for our case study.
Okay. And now you are working for updating this database, let's say, with new data, maybe for new plants, or this is to keep the model working, or?
Yes, I was still developing this model, and in fact, here in Chile, there is a project. It's a national project, and the idea of this project is called Cyclodata. Cyclodata have these objectives to collect data from all the country and disponibilize all this data for the for LCA analysis. And my work is part of these objectives to collect to give this data for public use.
Interesting. We have one question from Ilham, who asked, I didn't understand localized design.
Okay. We were talking about localized design. We were talking about consider specific parameters, such as, for example, the level of the corrosion level, the corrosion classification of the soil, the corrosion classification of the atmosphere. And this specific data give us information in order to design components for the conditions. For example, in the case of the mounting structure, we can share the thickness of the galvanized in the mounting structure if we consider the classification of the soil. No? So in the parametric model, we consider all these characteristics.
In order to quantify, let's say, the quantity of material that you need in your inventory.
Yes.
Okay. Okay. Thank you, Denet. Thank you very much. Now we will move to our third presentation with our third speaker, Ana Bargues from Becquerel Institute. So Ana is a PV analyst in Becquerel Institute since 2024. She's based in Lyon in France. She has a background in mechanical engineering, specialized in energy system at INSA Lyon. And today she contributes to Research European projects, many like Nexus, Seamless, Valhalla, etc. And she will present today social LCA for PV methodology. So Anna, the floor is yours.
Hello, everyone. Can you see my screen?
Yes.
Okay, great. So thank you, Noah, for the introduction, and thank you for everyone who's here today. So today, with this presentation, my goal is to give you an introduction to social life cycle assessments. So I will call it social LCA a lot. This presentation is meant as an overview. So I'm going to focus mostly on the methodologies and their limitations, and also why they matter. So social LCA is a very large and also evolving aspect. So there is a lot more details, but I won't have time to go too deep today. I will just hope that my presentation will give you some kind of foundation and understanding of what social life cycle assessments is.
Okay.
So first, I will give you some introduction defining what exactly is a social LCA and also its objectives. Then we look at the state of the art on social LCA and mostly on the methodologies, studies, standards, everything that happened before. And next, we'll go through social indicators and also 3 main databases used. And finally, we'll discuss why social LCA matter, both for responsible business and also for policymaking. And at the end, I will conclude and also give some discussion points that we can maybe dive into later if we have time. So first, for my introduction, social life cycle assessment, it's an evaluation of the social and also socio-economic impacts of a product or a service throughout its whole life cycle. So from raw material to manufacturing, use, and also end of life. So it complements environmental LCA by focusing on the human and social dimensions. Things, for example, like working conditions, human rights, fair salary, community well-being are the themes that we will look into social LCA. Social LCA is also aligned with the UN Sustainable Development Goals that you see on the right, especially those related to decent work, reduced inequalities, responsible production, and also sustainable institutions. The main objective of these assessments is to identify, assess, and also improve social performance all along the value chain. It can help integrate social sustainability into design and also into policy making. It's important to note that contrary to environmental LCA, social LCA is currently not a mandatory reporting requirement. It remains today a voluntary tool. It's used mainly to guide businesses and also support responsible decisions. So for the methodology, the basic steps can be recognized from Cristina's presentation and also much larger subjects, any kind of environmental LCA methodology. It's the same four main phases. These steps for social LCAs, they are defined in the 2020 guidelines from the UNEP and CETAC. So the first step is goal and scope definition. It's about defining the purpose of the study, defining the system boundaries, and also relevant stakeholders. Then we have the inventory analysis. So it's about collecting data on social and economic aspects throughout the whole life cycle of the product or service. And then we have the impact assessments. So it's about evaluating, for example, potential hotspots for social risks or social benefits. And then at the end, it's about interpretation, sorry. So it's about analyzing the results to identify these hotspots, to summarize the findings, and also to be able to do some recommendations for improvements. So for the structure, it's really similar to environmental LCA, but the differences, they lie in what we will measure. So for example, instead of CO2 emissions or carbon footprints, we will evaluate how products and processes will affect societies and people. So regarding the state of the art on social LCA, we will see how it has developed over time. The first concept of social LCA, they appeared in the 1990s, so approximately 30 years later than environmental LCA. So at first, we have a first, I would say, first steps from 1990 to the early 2000s. Then it can be changed because of the UNEP first guidelines in 2009. That brought some structure to the methodology. Then from 2013 to 2019, we can see some major progress. For example, new databases such as PSILCA were developed. And finally, in 2020, the guidelines from UNEP were strengthened, and also they are now the structure that are followed by most of the assessments. So for social LCAs, this is the social impact indicators. So like I said before, for environmental LCA, we are going to look at carbon footprint or CO2 emissions or toxicity. Here we are going to look at some of these social impact indicators. They are divided into stakeholder categories. So they are four: about the workers, the value chain actors, the society, and the local community. Here in this table, it's some examples of indicators, but in the databases that are mainly used, we can find at least 50 of them. So it's very important to maybe in the goal and scope definition step of the methodology to try to reduce the list of indicators, maybe try to see in regards of the project, the current project or the task at hand, what are the indicators that we are going to look at, because it gives a much more comprehensive analysis than if we look at all 50 indicators. So I was talking about databases. Here I just compile some characteristics from 3 regularly used databases. The first one is the social hotspot database. It's useful for screening studies. It offers quick identification of social risks across global supply chains. We also have the PSILCA database that is used in Open LCA. It includes over 70 social impact indicators and covers 189 countries. And then we have also SOCA. It's an add-on to EcoInvent. And this one can allow the integration of social and also environmental LCAs in one software. So that's one of its qualities. Each database has its strengths and also limitations. So the choice depends on the study at hand, its objectives, the data availability, and also the required level for details. Now, to answer the question why social LCA matters, first regarding the business side, social LCA plays an important role in supporting responsible business practices. It contributes to corporate social responsibility, so CSR, by identifying labor, human rights, and community-related risks all across the supply chain. It can help companies strengthen their transparency and also accountability, and it can guide them towards socially responsible sourcing and innovation. So at the end, it really aligns with ethical and sustainable operations as a whole. And then it also is very interesting in terms of policy, because from a policy perspective, social LCA provides it can provide recommendations for designing fair and inclusive sustainability policies. So it can support the inclusion of social criteria, for example, in the strategies for circularity and sustainable processes. And it can also promote stakeholder engagements, helping ensure that the energy transition benefits both the people and the planet. So to conclude on my presentation about social LCA methodologies, the social assessments can complement environmental LCAs by addressing the human and ethical dimensions of sustainability. Like Cristina said before, in sustainability, we have the environmental side, we also have the social side, and also the commercial side, I would say the cost side. So that's why it's important. In the PV industry, it can help to identify social risk associated with material sourcing, for example, and also manufacturing. To looking at current databases, we can see that they can provide structure, but there is also a need to improve the data quality because these databases, they have sources and information that might be a few years old. And in terms of social and socio-economics aspects, it can change rather rapidly. So that's why data quality is very important. So the future of social LCA can also lie in better integration with environmental LCA. How can we combine the two to get results that can help us carry on in a direction of just like more sustainable practices? And ultimately, social LCA can bridge the gap between innovation and also social responsibility. So that's what I hope I could give to you some information about that. I put some question in this slide. The goal is not really to answer them today. I'm not sure if there is one right answer for them, or maybe just some ideas that what could be improved. But so first question that we can maybe think of is, should social and environmental LCAs be combined to have one whole sustainability assessments, or should they remain separate tools? What are the main barriers to collect reliable social data for innovation and emerging technologies? And also lastly, how can social LCA results be integrated into decision-making, policy-making decisions? So, thank you for everyone's attention. And if you have any questions, feel free to ask me if something was not clear. It's a very quick overview to introduce the concept of social LCA, but I can answer any question you got.
Thank you, Anna. Thank you for this interesting presentation. I don't know if are there any question. Please feel free to raise your hand or put your question in the chat. Okay. Maybe I have one question for you.
Yeah.
Just curious, I'm sure that you did already the exercise for social LCA for PV modules. So could you give us, let's say, the main contributor? So for example, for LCA, we know that the main contributor is the module, for example, with polysilicon, etc. And from social impact assessment.
Yeah, so I did some studies for social to the PV sector. I don't know if there is one answer that remains the same for different studies because it really depends a lot on the country. So the assessment is evaluating the risks for one, I don't know, material on one process for each country. So from one country to another, it changes a lot. So I would say the main contributions, they come from the responsible raw material sourcing because of the social risks that are linked to sourcing such materials in some countries. And there is also a risk that come from the energy mix, for example, and it's really country dependent.
Okay. Thank you. There is a question in the chat, so maybe I'll let you answer it.
I'm doing my thesis on socio-economic impacts of renewable H2 projects based on a study case in Chile. Are you aware of key social indicators along the life cycle of PV project that we should not leave out? So about the social indicators, it depends a lot. you can do a study looking at all of them, and then in the report or in the results, just talk about the indicators with the most risks, the most impacts. But you can also do a selection process before the calculations. It really depends on the task at hand, like what you want to look at. Do you want to look at the workers? Do you want to look at the society or the community around it? Or maybe just the value chain actors? So I don't know if there is one good answer for this. It really depends. But in the studies that were published about social LCA, we can see both. One case of just calculating all of the indicators and then looking at the ones with the most impacts, or in other cases, just selecting beforehand, I would say 10 or 15 indicators to really fit with your goal and your obstacles at hand. I don't know if it's helpful. I would say that a lot of them, in the second case, the one with selecting indicators, they are, a lot of them are the same in several studies, because there are some indicators that people will look at first, I would say, or maybe they think it's most relevant in terms of social study. Like in the social indicators, we have indicators about renewables and environmental impacts, but in the studies, they will look first at, I would say, forced labor, child labor, corruption, things like that.
Okay. Thank you, Anna. So thank you very much. Thank you for all our speakers for this presentation. So now we will move to the, let's say, panel discussion. So the concept is really to let the audience ask questions and interact with our speakers. So be free to raise your hand or directly and open your microphone and ask the question, or we still always with the same, or asking by chat your questions. Okay, and maybe to inspire the audience, I will start by first question for the three of you. So today we see that we have challenge about quality of data. We look at LCA methodology, social assessment. So do you think that we need today to combine between social and LCA methodology to harmonize both of them in one methodology? Or do you think that we need to treat them separately in a context of sustainability? So what do you think about this combination of social and LCA assessment for PV modules?
Yeah, maybe I can start.
Yeah,
I don't have really an answer, but more just thinking out loud. I think for now, especially the social LCA methodology is still ongoing towards a standardization. And there are a lot of impact categories that are overlapping. For example, in the social indicators, you can find some indicators related to the climate change or the raw materials. And so I think that what we need is more an alignment between these two methodologies. And then after that, it would be useful to combine them in one assessment. But I think that it will be always important to show the results separately for each impact category, because the more we combine all the categories into one single score, for instance, the more we will lose for transparency and accuracy. So it's good for communication, but then it's also important to report all the single impact separately. But yeah, what we need for now is just an alignment between these two methodologies because it's a bit overlapping right now. And yeah, we need very different input data sets to perform the two analyses. So also alignment on the input data that are required would be useful.
Okay. Anna, do you want to add something?
Yes, I agree that, like we said before, for a really complete sustainable assessment, we need to look at both aspects. But it's true that to really put them in parallel in one study, it's not easy because the databases are not the same. And so I think it's a good thing to combine them, but they should remain separate databases, and maybe we have to look very clearly at, like, for example, one environmental assessment could say that, oh, this material is very good for the environmental aspects, but it's not good for the social ones. So then if that happens, we can ask the question, okay, so what should we do? Because one study say one thing and the other study says the opposite. So that's also a case of, should we prioritize something like one or the other? That's some questions. I don't really have answers. It's just ideas.
Yeah, I think in that case we will talk about multi-criteria decision making, and we need to find the tool in order to aggregate all the indicators. But as you mentioned, the question is, what is the priority? So, okay, Denet, I don't know if
Yes, I think the analysis depends of the perspective, the objective. Because, for example, from a designer perspective, it's important to consider all the aspects, technical, economical, maybe social. So depend of the scope of the analysis.
Okay. Thank you. I don't see questions, so maybe I will move to my next question.
We have
have
one
one?
raised hand.
Oh,
Yeah.
great. Okay.
Hello.
It's in the chat. Oh, hello.
Hello.
Thank you for your wonderful presentations. Firstly, what do you think about to categorize the environmental impact of the technology? I mean, it will be the first step to categorize the best environmental performance, the second and third, blah, blah. And then for the second stage, to analyze, to make the social impact analysis on these scenarios. I mean, the first step will be we'll be producing environmental scenarios based on LCA, but the second one will be the social LCA on these scenarios. I don't know which one is better to follow the ethic ways. I mean, which we will prioritize first the environment or social aspects. I'm not sure from now, but what do you think about the categorizing points on first the environment and then second social?
Yes, I don't know if Cristina, you want to answer? But
yeah, you can go.
I think it's a good idea to start from one aspect and then go from there, because it gives a clear direction and the study would be more structured. And also I think it's kind of logical to start from environmental, because like I said, there are mandatory criteria for environmental to have a product be commercialized. There is today no such criteria for social that can be measured through LCA. So yes, for now, that might be the logical way to go, the direction, like starting from environmental, and then when it meets the criteria for environmental, look at social and what can be improved.
Thank you, Anna.
Yeah, I agree on that. And this is also actually what is currently done usually in our projects. We always analyze the environmental aspects and then the social, not because the social is less important, but just because the methodology of the social is derived to the methodology from the methodology of the environmental LCA. And so, yeah, it's more methodological reason than importance reason. But yeah, that is how it's treated now, at least in the projects. And it would be also useful to treat it in this way for eco-labeling purposes to have, I don't know, a product passport with the environmental impact and parallelly with the social impact visualized in the same product passport, for example.
Thank you very much for your comment.
Thank
Now
you for your
it's more
question.
clear for me. Thank you.
Another question from the audience?
No, but before we move to the next question, can we take a group picture just for the recording of the project? If you want, you can turn on your camera or not. It's totally up to you. But Delfina will be happy, I think.
Yeah, sure.
I will take a screenshot.
Perfect.
Thank you.
Okay, thank you. I don't see hands raised. Question from Ioannis. Yeah, Ioannis, go ahead.
Well, I wrote it also in the chat. From an innovation point of view, I don't know if my question is valid. If you had to indicate one innovation to address urgently to develop LCA for diverse climatic conditions, what would it be? And another question, a bit relevant to this, if there is a kind of standardization framework in LCA methodologies. Yeah, I don't specify who to answer, so yeah. Perhaps more, I think, to Denet, because you addressed desert-specific conditions, so.
Sorry.
Yeah. I will repeat perhaps.
Lost.
I saw your presentation about desert-specific LCA. So
yes.
My question is, let's say, okay, on this basis, if we want to extend it in other diverse climate-specific conditions, what is, let's say, the main innovation in the current methodologies that we need to address, or the main feature?
Okay, I think it's important in the case of specific conditions to consider, for example, the specific losses in the depends of the scope. If it's a PV analysis or in the case of PV plants. But consider the specific losses is important, and from the point of view of LCA methodologies, I think the parametric analysis is necessary in order to understand the contribution of one parameter per time. It's important because we don't have data at an international level to consider. So this is a very interesting question, because, for example, in our case, Chile is not a manufacturer PV country. We are an usuario.
Yeah.
Yes. And for us, it's important the direct impact in our conditions. So I think it's necessary to make a zoom to the specific design, the specific typologies that you have in your site, and consider that.
Okay, thank you, Denet.
So thank you. I think that we are running out of time. So thank you all for Pirzas, for your presentation, and hope we will have another version of this webinar with more results for LCA of PV systems. So thank you very much, and see you soon.
Thank you
Thank
all for
you.
participating. Bye-bye. See you.
Bye.
Bye-bye.
Bye.
Bye.